Hello everyone, I'm Andrii Karpenko and I'm glad to represent our article with name Analysis of Trade-off in Fault-tolerant Distributed Computing and Replicated Databases with my scientific advisor Andrii Karpenko in letter 6. So let's begin. In this slide, you can see the content of our presentation. First of all, we will talk about CAP and PACLC theorem and discuss their limitation. Next, we will talk about different consistency models and discuss trade-off between core QoS properties of every second creates a large amount of information by people. Internet companies NoSQL databases are a great fit for many modern applications such as mobile, web, and gaming that require flexible, scalable, high performance, and highly functional databases. The flexible data model makes NoSQL databases ideal for semi-structured and unstructured data. NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. The CAP theorem defines a qualitative tree. The PACLC theorem is a further refinement of CAP theorem. It suggests that in case of partitioning of the distributed computer system, one has to choose between availability and consistency. Else, in the absence of partitions, the replicated system still faces a trade-off between latency and consistency. Through this theorem, help developers understand system trade-off between consistency and availability and performance. There are no methods available that allow interplaying consistency gains, availability, and latency in quantitative way. Besides this, these theorems do not take into account other fundamental trade-off, for example, between durability, latency, energy consumption, availability, and consistency. Data consistency model define a contract between a replicated data store and its users, in which the data store specify guarantees on the results of read and write operation in the presence of concurrent users' requests. There are two major groups of consistency models. The first one guarantees a central state of data store for all users, data-centric models. The second one provides guarantees only for individual user, client-centric models, while the data scene can be varying from users to users. In this slide, in this picture, I illustrate else divided types of these uh, major groups. System consistency, availability, and latency are tightly connected. Availability can be interpreted as a probability that each request eventually receives a response. through in many real systems, a response that is too late is treated as a failure. If minimum latency is a top priority, users should consider a weakness consistency level. For example, 1 and its variance 1 all and other. If consistency is the top priority, users should opt for a stronger consistency setting, which, however, warns system latency. For example, in this picture, a quorum consistency level used for both write and read operation always ensures a strong consistency, trading off between reads and writes latencies. The strong read consistency is also provides the all consistency level is used to read data, while the one consistency level is used to write and vice versa. In the first case, the performance given to minimizing writes latency, while in the second case, the minimum reads latency is ensured. Durability is the ability of the system to keep the committed data consistent after crashes, driver failures, power outages, or other form of corruption. For example, Cassandra NoSQL database flushes a commit log to disk every 10 seconds by default. Thus, if a power outage happens right before writing the commit log to disk, a system could potentially lose up to 10 seconds of data. Nevertheless, transaction commit logging cannot prevent data loss in the event of a disk failure. If it happens, lost data could not be restored on the crashed node, only if the system replicated data across multiple nodes. Thus, a higher replication factor improves durability property of a system. However, it affects system consistency and latency depending on the choose consistency level, as shown in this picture. The higher consistency level, the more replicas are requested simultaneously. This increases the overall energy consumption, taking into account additional power spent on transmitting request response and propagating updates over the network. In turn, the greater distance between replicas, the more energy is consumed. Thus, the replica factor and consistency levels contribute together to the overall energy consumption. The replication factor can be seen as the dominant aspect of system energy consumption, while consistency level adds a variable component. Cassandra is an open source NoSQL database that offers a set of unique features, for example, to enable consistency level and replication factor. It's very popular solution in scope, web application, and mobile that can use NoSQL solutions. The Cassandra database offers developers a unique opportunity to tune the consistency and settings for each read or write request we mentioned in the previous slide. Besides, it's possible to guarantee strong data consistency by coordinating consistency setting for reading and writing requests to ensure that the sum of nodes written and read is greater than the replication factor. So in this slide you can see shortly description of our experiment. We created a cluster with 3 node and management instance where we test using YCSB test framework to view our average latency. So in this slide you can see results representing as a diagram, and when workload reaches the maximum Cassandra throughput, delays increase in expander progression. You can see this in the picture 6. Picture 5 and 6 clearly show performance benefits offered by weaker consistency settings in the case of the heavy workload. It also the delays become highly volatile when Cassandra operates close to its maximum throughput. It's represented in picture 6. In conclusion, one should say that we define CVP and PICL set theorems and extend to them some parameters. And also we show results of our experiment that consist of 3 nodes Cassandra clusters and to show how to depend latency of current workloads between system consistency, availability, and partition tolerance. It declares that the only 2 of the 3 properties can be preserved at once in the distributed replicated system. In this slide we can see examples of databases that can ensure consistency and availability, such as MS SQL, Oracle, MySQL, and others. Availability, partition, Cassandra, DynamicDB, and others.